in honor of Star Wars week, since Monday was May the 4th, I found the Star Wars PowerPoint, so I'm going to see if I can keep this theme going all week. We'll see. All right, so square root. So we're still working on our same TEAC, solving quadratic equations, having real solutions by factoring, taking the square root, which is what we're going to talk about in this video, completing the square, and applying the quadratic formula. Okay, so we already did factoring. That was last week, and you reviewed that yesterday. So now we're going to go on to square root. Okay, so for your learning targets, you're going to need to be able to factor this perfect square trinomial, and that'll come up later. Remember, that's when you factor it and you end up with, like, in parentheses x plus 2, and then in parentheses x plus 2, so you could write that as x plus 2 to the second power, and that's going to come up later. So you got to remember how to do that. You're going to need to use inverse operations, so you need to understand that to undo squaring, you take the square root. And then finally, like the big learning target, like you can solve the quadratic, find the roots and the solutions of them by using the square root method, or just solving them, okay? All right, so remember, we could have no solution where the parabola does not touch the x-axis. You can have one solution, so you get one value for x, which I think you saw in the video last week, Dr. Berger video. He had one that only had one solution, or you could have two solutions. Okay, so keep that in mind. All right, so when do we use the square root to solve quadratic equation? It's the most direct way because you pretty much just take the square root of each side and you're done, but it has to look a certain way in order for you to be able to do that. So you have to have the x squared term and no x term. So you need the constant and the x squared. So the equation needs to be in the form x squared equals c, because then you can just take the square root of each side and you're done. Okay, so let's see what that looks like. So for example, here I have f of x equals 3x squared minus 75. So, okay, so the first thing we have to do, remember, we're looking for the zeros, so we are going to set our equation equal to 0. Now I want to try to use the square root method because this is not going to factor necessarily very well. You could factor a 3 out because 3 goes into 75, so we could go down that road. That's fine. Whoops. So either 3 equals 0, which is just ridiculous. You can throw that solution out as you saw in the video last week, or x squared minus 75 equals 0. So you could definitely go that way. I'm going to go back though and use this square root method because I see I have an x squared, I don't have an x term, so I'm going to try it. So a lot of times you just try things and see if they work. If not, you go to another method. So I'm going to add 75 to both sides, or move this 75 over, so now it's positive. Isolate my variable, so the first thing I'm going to do is divide by 3. 3 divided by 3 gives me 1, so I get x squared equals 25. This makes me happy because I know if I take the square root of x squared, I get x. If I do that to one side, I have to do it to the other side, and the square root of 25 is plus or minus 5. So this will have two solutions, which you could verify by graphing. Okay, so remember the square root of 25 equals 5 because, hang on, my dog was itchy. Okay, so is 5 because 5 times 5 is 25, but negative 5 times negative 5 is also 25. So we say that the square root of 25 is plus or minus 5, and you can just write it like that. Okay, or you could write x equals 5, x equals negative 5. Okay, so that's how that works. Get another example here. Y equals x squared plus 9. So again, we're going to put in a 0 for y. Set the equation equal to 0. Now if I write it, I'm going to write the 0 on the other side so I don't have to flip it around again. So once I isolate my variable, I don't have to divide by anything because there's no coefficient other than 1. I'm just subtracting 9 from both sides and I get this. Now I take the square root of both sides, and the square root of x squared is x, but the square root of -9 is not a real number. Okay, you can take the square root of negative numbers, but they're imaginary. So here we say this has no real solution. So no solutions, or you'll see them say no real solutions, because there is a solution to this. It's imaginary. I believe you'll look at that sometime later in maybe pre-cal, maybe calculus. You'll look at imaginary solutions, okay? But this has no real solutions. And if you think about this, think back to our quadratic transformations. What does this say? This says I'm going to take the parent function and put it, translate it up 9 units. So now it's going to look like this, and it's not going to touch the x-axis at all. So that means it has no solution. Okay? And you'll see as we're doing these, this transformation will come back into play again and again and again. Okay, so if you look at that and say, well, that's just the parent function translated up 9, so it's not going to cross the x-axis, totally okay to say this has no solution because it is a translation of the parent function 9 units up and therefore will not cross the x-axis. I would totally be okay with that explanation. That would make me very happy. Or you can solve it and see that once you take the square root of a negative number, you have no real solution. All right, so where does this whole perfect trinomial come in that we talked about earlier? Perfect square trinomials. So remember that if you take a plus b quantity squared, like here, that's what I'm talking about, you're going to get a squared plus 2ab plus c squared. If I take like x plus 3 squared, I get x squared plus 6x plus 9, and the same thing happens, only a negative sign there. So if I have one of these trinomials, I can factor it this way and then take the square root. Okay? All right, so let's look and see what that looks like. And then I can solve for, you don't have to do another step, solve for x. Okay, so let's see what that looks like. And I probably did this one, wouldn't you know it? All right, so here I can't just set, I can't just use square root, put the 9 on the other side because I have this middle term. I have a 6x, I have a b term. Okay, so you could factor this into 2 binomials. If you do that, you will see that it is this. Okay, and then you could say, well, x plus 3 equals 0 and solve for x. The other thing that you could do here is say, well, this, since this is squared, I can take the square root of that. So I get x plus 3 equals 0, and therefore x equals -3, and this will have just one solution. Okay, so it's only going to cross the x-axis one time there at -3. Okay? We'll talk about that in a minute. Keep that in mind. All right, so this comes in handy if they give you, if somehow you're doing something, you end up getting to this point where you have a quantity squared, you still undo the squaring by taking the square root. Okay? If I was doing this, I probably would just go here. My process would be here, and then from here I would just say, well, x plus 3 then equals 0. So x equals -3. Okay, now remember what I said about the transformations. If you look at this here, so let's take out what this is equal to. Let me go over here. So I end up getting f of x equals x plus 3 squared. That's a transformation. It's going to translate 3 units to the left. So this is a parent function that's translated 3 units to the left since it's plus 3. So then you know that it has one solution at x equals -3. And again, if you recognize that, you are certainly welcome to tell me that. Okay? Or you can solve it by factoring. You could use the square root method here as well. All right, one more example. I tried to think about kind of weird things that might happen. Like, what if it's not already equal to 0? Or what if you have it equal to a number? All right, so for here, this is not in the form ax squared plus bx plus c equals 0. It has to be in that form for me to solve it. Since the solution is the x-intercept, which is the zeros, I have to have my function equal to 0. So I'm going to add 16 to both sides to make that happen. So 9x squared minus 24x plus 16 equals 0. Okay, now I'm happy. Now when I look at this and I see 9 and 16, those are both perfect square numbers. 3 times 3 is 9, 4 times 3 is 16, or 4 times 3 is 16. 4 times 4 is 16. But if I do 3 times 4, I get 12 times 2, there's my 24. So I know that's a perfect square trinomial. So I could write this, you might see it right away as 3, that's minus, sorry. 3x minus 4 squared equals 0. Okay, so if you see that right away, great. If not, that's fine, because more than likely you will be trying to factor this. I know I'm going to do 3x and 3x, and minus is going to give me a positive 16, 4 and 4. Then when I check, I see 12x and 12x, which gives me my 24. Okay? All right, so if I see it as a perfect square, I take the square root to undo the squaring, and I end up with 3x minus 4 equals 0. Now I just solve for x. Square root of 0 is 0. So I add 4 to both sides. I get 3x equals 4, divide by 3. So I get x equals 4/3. And I only have one solution, since really this is going to be, the 3 is going to make it, let's see, the 3 is going to make it narrower and it's inside, so we're going to talk about a horizontal compression, and the 4 makes it go 4 units to the right, okay? But the 0 is going to be 4/3 because of that multiplier of 3 in the front. Okay, so they give one solution that way. So perfect square trinomials will give you one solution. If you just have like the difference of two squares, like x squared minus 25, x squared minus 16, that's going to have two solutions, because when you take the square root of things like 25, 16, 9, you get plus or minus 3, plus or minus 4, plus or minus 5. And then if you end up taking the square root of the negative number, you're not going to have a solution, no real solution, okay? All right, so just another way to solve by thinking about that square root, because sometimes you might not see the factors. So like if you have x squared minus 25, you might say, well, that's x plus 5 times x minus 5, and you can go from there. But if not, remember, if you can always take the square root to undo the squaring. Okay, you can't do this though. I just want to make this clear. If I had x squared plus 2x, you can't take the square root of that. That's not going to do anything. Okay, because you can't take the square root of that is just the square root of 2x, and that's not going to help you out. Okay, it has to be something like x plus 2 squared. Then I could take the square root and these things cancel each other. Okay, all right. So, how do you feel about the learning targets? Think about what we did. How do you feel? And I just love this little Yoda guy. I am the math is with me. Do you feel like that? Or are you feeling a disturbance in the force and you're not really sure what you're doing? Okay, I'm going to put this into an ed puzzle, so you can type your answers to which picture or meme or whatever you want to call this most describes how you're feeling right now. Okay. May the force be with you.